Hi, in 5.4, we're solving compound inequalities. Compound inequalities are just two inequalities in one, basically. So what I'm going to do is you want the middle of the inequality to just have a variable by itself. So in a normal inequality, we would get the variable by itself. You're going to do the same thing in this one. And what you do to one side, you do to all sides. So example, in number 1, it says solve 7 is less than z plus 2 is less than or equal to 11. So what I'm going to do is I'm going to subtract this 2 from the middle. If I do that, though, I have to subtract it from all sides. So the z will be alone by itself in the middle. 7 minus 2 is 5, and 11 minus 2 is 9. And that's it. We've solved it. I know that because the z is by itself in the middle. Now, if we wanted to graph it, and you are going to have to graph it in this section. So what I'm going to do, I'm just going to make it easy for you and put a 5 and a 9 on the number line. Okay, since this symbol right here is a less than symbol, it's going to be an open circle right here. We're going to have an open circle. And since this is less than or equal to, I'm going to have a closed circle right here. Now, the easiest way for me to tell you is that z is between 5 and 9, literally. Right here, it's between the 5 and the 9. So I'm going to shade between the 5 and the 9. And that is my answer. Now, to explain that a little better, right here you can see z is greater than 5, or 5 is less than z. And then right here, z is less than or equal to 9. So what that tells me is z is less than or equal to 9, so it would be going this way, but it's also greater than 5, which is this way. So in the middle right here is the only point, the only spot that both of those things can be true. Okay, let's do another one. All right, I'm going to rewrite this inequality that I have here. I'm going to write -4 is less than -5x minus 9 is less than 11. So again, I'm trying to get the x by itself in the middle. So I'm going to add 9 to both sides first, or all three sides actually. When I do that, -4 plus 9 is 5, is less than, drop that down, -5x is less than 11 plus 9 is 20. So now I need to divide by -5, again to get the x by itself. And I'm going to divide all sides by a -5. So I've got 5 divided by a -5 is a -1. And on this side, 20 divided by a -5 is a -4. And then I have the x by itself in the middle. Well, what happens is when you divide by a negative, your inequality signs flip. So that happens. But no math teacher likes inequalities written like this. We always like them from least to greatest. So I'm going to reverse this whole thing and say -4 is less than x is less than -1. Now, I want to be able to graph this on a number line. So I'm going to draw my number line, and I'm going to put my -4 and my -1, and these are both less than signs, so they're going to be open circle. Now, the thing is, we've got -4 is less than x, but x is less than -1. So x is going to have to be in the center of those right there. Okay, this problem is also a compound inequality. It's just written with the or instead of and. So if you see one compound inequality where it's all together, that means and, but these do not. This is saying or, how it's written. Okay, so let me show you the difference. All right, so in this problem, we're just going to solve it two separate problems. So I've got I've got 4k minus 7 is less than or equal to 25. And so I'm going to add the 7 to both sides. And I've got 4k is less than or equal to 32. So I'm trying to get the k by itself. So I divide both sides by 4. And I get k is less than or equal to 8. Or let me work out this one. So this says 12 minus 9k is greater than or equal to 30. So I would solve this by subtracting both sides by 12. And we get negative 9k is greater than or equal to 18. When I divide by a negative 9, you should know by now the inequality sign flips because I'm dividing by a negative. 18 divided by a negative 9 is a negative 2. So these are my answers, okay? So if I was just wanting you to list the solutions, that would be it. But I do want you to graph these on a number line. So this says, let's do the first one. We've got k is less than or equal to 8. So if I have an 8 on a number line, it's less than or equal to, so it's going to be a solid circle, and it would be less than. So we're going to shade every number less than 8. Now, if I do the second one, a negative 2, we can just say is somewhere down here. So k is less than or equal to negative 2. Well, that point is already included in the other shading. I can graph it and you can see how they overlap each other. So since one is overlapping the other, you can just draw it with the 8 because that it already includes the negative 2. So this would actually be the graph that you would give me. Okay, let's try another one. Okay. All right, number 4 says 11x minus 9 is greater than 13, or negative 4x minus 4 is less than 8. So I'm going to solve this first one. So I'm going to add 9 to both sides. And that cancels out. So I get 11x is greater than 22. Divide both sides by 11 to isolate the x. I get x is greater than 2. Or, now let's solve this one. So I'm going to add 4 to both sides. When I do that, we cancel out. And I get negative 4x is less than 12. So in this step, I'm going to divide by negative 4. So I get x. We're dividing by negative, so make sure you remember to flip that sign. 12 divided by negative 4 is a negative 3. So I'm going to graph this on a number line. So I'm going to go ahead and graph this one now. So I'm going to try it on the same number line this time. So if I have a 2, that would be right here. And then I can put my negative 3 right here. So I've got x is greater than 2. So that would be an open circle on the 2 and all numbers greater than that. Or x is greater than negative 3, which would be an open circle on the negative 3 and all numbers greater than that. So really you can see one is overlapping the other. And so I really can just list it because that includes the point that's for 2. So that would be your answer. I want to show you there's one more problem that you need to see. So this is also compound inequality where we're using R. So I'm just going to solve both individually. So we have negative 3p plus 1 is less than or equal to negative 11. So I'm going to isolate the p. So I'm going to subtract 1 from both sides. So I have negative 3p, those cancel out, is less than or equal to negative 12. And then I'm going to divide both sides by a negative 3. So I get p, flip the inequality because we're dividing by a negative. So p is greater than or equal to a positive 4. Or, there's nothing to solve with this one, so I'm going to just drop it down. P is less than 2. Now when I graph this on a number line, this is why I wanted to show it to you. 2 would be on the side, 4 would be over here from least to greatest. So P is greater than or equal to 4. That would be a closed circle, and you would shade all the numbers greater than 4. If I want to graph this part right here, P is less than 2, so it's going to be open circle, and you're going to shade all the numbers less than 2. So that's going this way. This is the answer, this whole thing, because you have a number line where the 2 points do not connect, the 2 shadings do not connect, but that's all right in this problem because they're going different directions, because we have P is greater than or equal to 4 or P is less than 2.